Sorry about the typo in this slide in class. Here I fixed the typo, and let's go through the solution of this type of problem. Notice that the utility function is the square root, the utility is the square root of income, and then she's earning $100,000 a year if there's good weather and $50,000 a year in hail. If there's a hailstorm, we assume those are the only two possible states. Probability of a hailstorm is 0.3, so probability of good weather is 0.7. And then we've got her considering this policy that costs $16,000 a year and it's full insurance. So if she loses the $50,000 of income because of the hailstorm, that's the insurance policy pays off by compensating her exactly for that $50,000. And we're asked to find what's the change in her expected income and what's the change in her expected utility. So the easy part, well, neither one is all that hard, but the easier part is just to look at what's the change in her income. And let's go ahead and do that. So without insurance, she, with a probability of 0.7, she earns $100,000. And with a probability of 0.3, she earns $50,000. And when we add those two up, her expected income is $85,000. And then with insurance, she is going to make, with a 100% chance, her income is equal to $84,000. If it doesn't hail, she earns $100,000 from farming, has to pay the $16,000 in insurance, and that's $84,000. If it does hail, she earns $50,000 from farming, $50,000 payoff from insurance, but she has to pay that premium. So she's nets $84,000. So notice that her income has gone down by $1,000. As far as her utility goes, we multiply probability times the utility of each outcome. So expected utility without insurance is equal to 0.7 times the square root of 100,000 plus 0.3 times the square root of 50,000. And that turns out to be 288.44. You can do the math to make sure I've not made a typo there. And then with insurance, she has a guaranteed level of utility that's associated with that guaranteed level of income. Her utility is simply the square root of 84,000, and that turns out to be 289.83. And so notice that her utility has gone up by 1.39 utils. And this little example explains why insurance markets work. This paying $1,000 to shed that risk makes the farmer better off. Remember, we care about our expected happiness, not our expected dollars in and of themselves. But the insurance company, by insuring many uncorrelated events, can spread the risk to close to zero and make money on that endeavor. So that's both sides of that transaction win, and we have functioning insurance markets.